Researchers at Chalmers University of Technology have come up with a surprising new building material, and it starts with something you probably already have in your kitchen: yeast. This innovative material is completely bio-based, 3D printed, and designed to replace products that are usually made from plastics, plaster, or synthetic fabrics. The construction industry is one of the world's biggest consumers of resources and a major source of emissions, so finding sustainable alternatives is becoming increasingly important. That's where this new material comes in. The team created it using a blend of baker's yeast, wood-derived cellulose fibers, algae-based alginate, plant-based glycerol, and water. Together, these ingredients form a soft hydrogel that can be shaped through 3D printing. The manufacturing process is surprisingly simple. The yeast is first heated to deactivate it, then mixed with the other ingredients to create a smooth paste. This mixture is printed at room temperature using air pressure, which means it doesn't require energy-hungry heating systems or extra support structures during production. The result is a low-waste, resource-efficient manufacturing method. One of the most exciting features is how customizable the material is. By adjusting the recipe, researchers can change its color, texture, and transparency. That makes it ideal for interior design applications such as decorative wall panels, room dividers, and screens that help control sunlight and daylight inside buildings. Natural pigments and even colorful yeast strains can be used to create different visual effects and patterns. What makes this approach unique is that the yeast isn't used for fermentation. Instead, it acts as the main biomass, giving the material strength, stability, and volume. Researchers also see potential in using waste products from industries like brewing and agriculture, turning materials that might otherwise be discarded into useful building components. Unlike traditional construction materials that are designed to last forever, this yeast-based material is biodegradable. Once its useful life is over, it can safely return to nature, supporting a more circular approach to design and manufacturing. There's still more work to be done before it appears in buildings on a large scale. Future studies will focus on testing its strength, fire resistance, moisture performance, and large-scale production methods. But the early results suggest that a future filled with sustainable, nature-inspired building materials could be much closer than we think.